Hello, this is Mr. Soy. Today we're going to be talking about function operations. And in particular, we're going to be looking at adding and subtracting functions, multiplying and dividing functions, and then another thing that they call composition of a function, or what I like to call nested functions. So we're going to be looking at all of those operations. The easiest thing that I always tell my students is think about a function as being nothing more than maybe a Lego, and that we're going to try to combine these Legos together to build something new. In this case, we're going to build a new function, something bigger that is composed of smaller components from other functions. So again, Legos. All right, well, the first thing we're going to start with is we're going to start with adding and subtracting functions. The functions that I've listed at the top there, f of x equals 3x minus 8, g of x equals x squared plus 6, and h of x equals 2x plus 1, all divided by 3. Those are the functions that we're going to use as examples. So you can jot those down or just pay attention and watch what I do with them. Okay, so add and subtract. So let's take an example. Let's take f of x plus g of x. So in this operation, we're adding two functions together. The result is going to be a more complex function built from these other two. The way that we do it is we're going to write down each of the functions, and I always put them in parentheses, whatever it is I'm plugging in, plus g of x, which is x squared plus 6. Okay, so we don't want to leave the expression as that. We want to simplify it as best we can. Okay, so I've got 3x minus 8. And then when I distribute the positive through, it just keeps everything the same sign. So I've got x squared plus 6. All right, got rid of my parentheses. Now I'm going to combine my like terms, and I'm going to reorder it from to put it into our standard form of a polynomial. And that means that the highest power first, x squared. And I've got 3x. And then finally, I can combine my negative 8 and my positive 6, which ends up with negative 2. And so our new composite function from adding two different functions together ends up being x squared plus 3x minus 2. We can do the exact same operation with subtraction. It's pretty much the same, but I want to highlight it because there is something that a lot of students sort of fail at. And when they do that, unfortunately, they have problems then with the answer. So let's do this. Let's do g of x minus f of x. So again, we're going to put in parentheses each of the functions. So g of x is x squared plus 6. And then we're going to subtract from that f of x, put it in parentheses, which is the 3x minus 8. And this is where a lot of students get tripped up. We have to remember that I have to distribute this negative 1 inside both terms of the f of x. When I do that, I'm going to end up with x squared plus 6, our g of x function, and then minus 3x, and then negative times the negative gives me a positive 8. So I've distributed the negative through. Now we combine our like terms and rewrite it in that descending power order. So x squared minus 3x, and then positive 6, positive 8 gives me positive 14. And that's really all there is to adding and subtracting functions. So we're just taking those functions, putting them in parentheses, and then doing whatever operation in between them that we need to add or subtract. Key thing on the subtraction is make sure that you distribute the negative, right, through the second term so you get your signs right. And that's where most students kind of mess up on that. Okay, so now we're going to look at multiplying and dividing functions, just more operations. And it's very similar to what we did with add and subtract, where I'm going to take a function put it in parentheses, and then I'm going to do the appropriate operation, multiply or divide, and then in parentheses the second function. And then basically simplify. So let's start with multiply, and we're going to do f of x times h of x. All right, so I've got two linear functions that we're going to basically multiply together. So in parentheses, I write them down. So the first one, f of x, is 3x minus 8. And I've got my multiply in here. And then h of x, which is 2x plus 1 all over 3. Okay, well, really what we have here is we have a fraction operation, right? So I can rewrite this then to be 3x minus 8 all over 1. And we're going to multiply that to 2x plus 1 all over 3. Basically, multiplying fractions, we multiply top to top. So I get 3x minus 8 times 2x plus 1. And then finally, 3 times 1, which is just 3. Now I need to do the multiplication up top. So you should remember how to do that. I'm going to basically do FOIL. And that gives me 3x times 2x is 6x squared. 3x times 1 is 3x. Negative 8 times 2x is negative 16x. And then negative 8 times 1 is negative 8. All of this is still over 3. All I have to do now is simplify, combine like terms, and I end up with 6x squared minus 13x, so negative 16 plus 3, and then minus 8, all of that over 3. I can take this further if I want and end up dividing each individual term by 3, so that would be 6 over 3x squared minus 13 over 3x minus 8 over 3. Not sure it really buys me a whole lot, but I can then simplify the 6 over 3, which just gives me 2x squared minus 13 thirds x minus 8 thirds. And that would be our new function after we multiplied f of x to h of x. Not always going to come out with a nice, clean, easy function, but it does give us a way to combine functions by multiplying. And there's going to definitely be times in the future of your algebra where you're going to need to do that. And then you need to know those simplification skills that we've practiced on and on so that you can reduce it down to a simple function. Okay, in our next example, we're going to do division. So we're going to take h of x, and we're going to divide that by g of x. Okay, well, now I just, again, in parentheses, I write down each individual function. So that's going to be 2x plus 1 over 3. And I'm going to put that over g of x, which is x squared plus 6. Copy dot flip gives me copy the top fraction, 2x plus 1 over 3. And then I'll flip the bottom one, which is x squared plus 6 over 1. So when I flip it, that ends up being 1 over x squared plus 6. Multiplying, we multiply straight across with fractions. So 2x plus 1 times 1 ends up giving me 2x plus 1. And then the bottom, same thing, 3 times x squared plus 6. Well, that ends up giving me 3x squared plus 18. At this stage, I can't really simplify this anymore. Sometimes you can, but in this case, I cannot. However, if I had a polynomial being divided by a polynomial, I would always check to see whether or not there is a chance that what I'm dividing by is a factor of the top polynomial. In this case, that is not the situation, so we leave it simply as 2x plus 1, all divided by 3x squared plus 18. And that's how we do division. Okay, and this last operation we're going to look at is composition of functions. I call it nested functions because that's really what's happening here. So we're going to basically nest one function inside another one. In other words, we take one function and make it the input to the other function. The one we're going to do is going to be g of f of x. So I'm taking the f of x function and I'm putting it into the g of x function as the input. And I want to know what function comes out of that operation. Okay, so again, first thing I do is I'm going to write out g of x, and I'm going to put in parentheses the x where the x would normally be, because I'm going to plug in the input into those parentheses. So normally the function for g of x is x squared plus 6. So what I've done is write in parentheses square plus 6. Now I'm going to put in what is plugged in for our input. Well, it's f of x. And f of x is 3x minus 8. So I write that in there, 3x minus 8. Okay, so now I've got to square 3x minus 8 and then add 6 to it. So I get 3x minus 8 times 3x minus 8. We've still got our plus 6 out here. Go ahead and do my FOIL or polynomial multiplication. So 3x times 3x gives me 9x squared. 3x times negative 8 gives me negative 24x. Negative 8 times 3x gives me negative 24x. And then finally, negative 8 times negative 8 gives me positive 64. And then, of course, I still have my 6 out there. All right, now all I have to do is combine my like terms and simplify this. So I end up with 9x squared minus 48x. And then 64 plus 6 gives me 70. And we are done. And that's the composition of function, also known as nested. The next thing I want to talk about real briefly is this notation, because they have notations that they use. And I think it's important that you understand the difference between the notation I demonstrated and the other notation that you might see in a textbook or on a test or something like that. All right, so what I've listed out here is the notation I like to use because it's pretty clear, concise, and makes sense. The operation I'm going to show you, it's not particularly difficult, but it's just a little bit different. So the way that they would do it for addition or, adding two functions is they like to write it as f plus g of x. It's subtle, but that's the way they like to do it. And then it's going to be the same for subtraction, for multiply, for divide, and then the composition one, they introduce a symbol that you're probably not familiar with. So let's do that. It is essentially like multiply, except it's an open circle. And that's the composition. So this is the notation you're likely going to see in the modern textbooks, online, things like that. I prefer, of course, this older notation. It's real clear and concise. But somewhere along the line, someone decided that this was sort of a shorthand notation. Either one works. Just be aware that when you see the one here, that's going to be that composition or nested. Okay, and so the second one that you list, so this is your first and second, the second one that you list is going to be input into the first function. So f of g of x. Okay. The last part we probably should talk about is evaluating function composition. So we know how to add, subtract, and whatever, and we can create a new function from that. But sometimes really all we want to do is be able to actually evaluate a specific composition. So using our same functions from the very beginning, our f of x, g of x, and h of x, we're going to go ahead and do a couple examples of what that looks like when we're evaluating. The first example we're going to look at is going to be a composition f plus h of -1. And so what we're doing is we're explicitly saying that we're going to plug -1 into both of our functions, f and h, for the x, and we're going to add the results of those together. Okay, so let's go ahead and just do that. So our f of x is 3x minus 8. So I'm going to plug that in. So it's going to be 3 times -1 minus 8. And from that, I'm going to add together our h of x. That's 2x plus 1 over 3. So that's going to be 2 times -1 plus 1 all over 3. And now I can just begin the simplification or the evaluation process. That gives me -3 minus 8 plus, this would be -2 plus 1 over 3. This gives me -11 plus, so I get -2 plus 1 over 3 gives me -1/3. Yeah, now I got to do that fraction math with a common denominator, so that ends up being -33/3 minus 1/3. -33 minus 1 gives me -34/3. And that would be our answer of evaluating that composite. In this one, we're actually going to look at the nested composition. So in this case, we're going to take f of g of x, and using their notation, that would look like f g of x, except we're actually going to plug in a value. We're going to plug in 2. All right, so what does that look like? Okay, so f, right, basically gets the output from g of 2. So my first step is going to be f of g of 2. Well, g of 2 is 2 squared plus 6. Which would be f of, well, 2 squared is 4, plus 6 is 10. And now I can do the outer function f of 10. Well, that's 3 times 10 minus 8. And that gives me 30 minus 8, or 22, and that's our answer. So again, this is evaluating compositions of functions. So we're not actually building a new function. We're actually plugging in values and doing the order of operation as appropriate to come out with a specific answer at the end. Hope this helps you all.